Instead of a plug door that gets jammed into its frame as the aircraft pressurizes, Boeing opted for an outward opening door. This allowed for more cargo space, but was not fail-safe like the plug design. So Boeing built what they believed was a foolproof locking mechanism.
What they do is they build in multiple redundancies to make sure the door is properly latched and does not open. And you build it in to a point of that it's extremely improbable that the door would ever open.
So what went wrong on Flight 811? The Campbells soon discovered that the problem lay in the design of the locking mechanism. To lock the cargo door on the 747, electric motors rotate C-shaped latches around pins in the door frame. A handle then moves arms, known as locking sectors, over the top of the C latches to prevent them from reopening. But as early as 1975, problems were found with the locking sectors. Kevin Campbell, an engineer by training, built a model to show the weakness in the Boeing design.
Initially, the locking sectors were made in aluminium, and in 1975, Boeing realized that they weren't strong enough, and they actually doubled up the aluminium to make it double thickness. But it still wasn't strong enough, and a lot of the airlines didn't even put the doublers on anyway.
The weakness of the aluminium drastically increased the risk of the door accidentally opening.
With the aluminium locking sectors, if the C-locks tried to backwind, open electrically, it would just push the locking sector out of the way. It just simply wasn't up to the job that it was designed for.
For 20 years, 747s have been flying with this crucial weakness. The Campbells wondered what else remained to be revealed. They redoubled their efforts to uncover the full truth behind the accident that had killed their son.
We bought a car and set off in the United States to see as many people who were involved with the accident as possible. We started at Seattle, down to Denver, across to Chicago, through to Washington, D.C., down to Kentucky, on to Miami, and back across to San Diego, back up through San Francisco, back to Seattle. And that was just one trip.
The Campbells soon found that a shockingly similar incident to Flight 811 had given clear warnings of the dangers in the cargo door. In 1987, 2 years before Flight 811, a Pan Am 747 had been climbing out of Heathrow when it failed to pressurize at 20,000 feet. The pilots had to turn back.
When they got back to Heathrow, they found that the door was hanging open 1.5 inches at the bottom, and all of the locks were open. When it got to the maintenance base, they found that all of the locking sectors were either bent or broken.
Why had the sea latches turned and bent back the locking sectors? Boeing claimed that the ground crew must have mishandled the mechanism.
The door had been closed manually, and what they said happened was that the guy wound the C-locks closed, 98 turns of a speed wrench. He closed the outer handle and then wound it open again. And to be in the position that they were found in when the aircraft got back, he would have had to wind them open 98 turns. And this is just absolutely ridiculous.
But the Campbells' investigation uncovered another vital clue to why the sea latches had turned. A report by Pan Am engineers highlighted problems with the door's electrical system.
It had a fault in the S2 master latch lock switch that should have turned off the power to the door when the outer handle was closed.
This was an alarming finding. When the outer handle was closed, the S2 master lock switch was meant to disconnect the power supply and stop the C-latch motors from turning. So could this have failed, allowing the motors to open the door? To find out, Boeing asked the airlines to do a simple test. Close the outer handle, then press the switch to open the door, and see what happens.
when they hit the switch, it actually worked. The Boeing thought, you know, this is not going to work, but it actually worked. There was power to the door locks with the outer handle closed, and the lock started to move, and it started to force the locking sectors out of the way. And a few days later, the airline started ringing in and saying it was damaging their planes. So Boeing stopped the test. But it meant that on those aircraft, the S2 switch had failed, which is a silent failure. And all of those aircraft were likely to have the same problem as 811. They were just waiting for a short circuit to open the doors.
The Campbells now became convinced that the accident on Flight 811 began with a failure of the S2 switch. Power remained on to the sea-latch motors. All it took was a short circuit in the 20-year-old wiring, which had been found to be frayed on other aircraft, to start the motors up. The aluminium locking sectors were too weak to stop the latches turning, and the cargo door burst open.
The National Transportation Safety Board determines that the probable cause of this accident was the...
After waiting a year for the NTSB report, Kevin and Susan Campbell expected it to match their theory of what had led to the accident on Flight 811.
I'd assumed that we would have a report come out that this was an electrical malfunction, and was staggered when they came out and said that the door had been mishandled.
The report focused entirely on the fact that the door lock must have been mishandled by the ramp attendant. That was disappointing, and we felt that they must have been at a different hearing from the one we were at.
So how had the NTSB come to their conclusion?
There was other evidence that we had found during our investigation of improper procedures by the United Mechanics and ramp people. So we were convinced that there was, we could use the word abuse being done on the doors. The doors were sort of abused and weren't maintained very well. We concluded that the probable cause was mechanical.
For the Campbells, the NTSB's failure to mention the electrical problems just wasn't good enough.
What they said happened was the door was closed, the locks didn't fully close, they're just partially closed, just hanging on the pins, and then they close the outer handle. But it just simply can't happen because that part of the locking sector is still intact. Just simply can't happen. You can't close the outer handle unless these are in the fully locked position. It's the only way that the outer handle will close. And just closing this manually, you can't exert enough force to actually damage this part of the locking sector. All it does is just butts up against there. If the locks aren't fully closed, it just simply butts up against them and goes no further.
They went back to investigating the accident on Flight 811 and soon found disturbing evidence of how it could and should have been prevented. After the Pan Am incident in 1987, it turned out that Boeing had issued a directive to the airlines on how to correct the weak aluminium locking sectors.
The airworthiness directive that came out was to replace the aluminum sectors with steel sectors that could not be bent. And there were some additionally some interim requirements for inspections to be performed until what they call terminating action, the steel sectors were installed.
The fix was cheap and simple, but getting it done was not.
The actual cost of the modification, changing these locking sectors to steel, was $2,000 per aircraft. But it took 10 hours to do it, and that's where the money was. Taking the aircraft out of service for 10 hours, that's millions of dollars.
The Campbells found that back in 1987, the Federal Aviation Administration, who were meant to enforce improvements, had given the airlines 18 months to comply with the modification. Within a year, Lee Campbell and 8 others would die in an avoidable accident. So why weren't the airlines